Hello friends, myself Dr. Nandakumar Raubavale from College of Engineering Ambazogai is going to deal with numerical methods in mechanical engineering. This is our 13th lecture. In previous lecture we have discussed ill conditioned systems of algebraic equation and partial pivoting. Today we are going to discuss complete pivoting and scaling, then combination of scaling and pivoting. So yesterday we have considered one set of equations. So those set of equations are like this. Point 0, 0, 0, 3 x1 plus of 3.0000 x2 is equal to 2.0001. So this was equation number 1, and another equation is 1.0000 x1 plus of 1.0000 x2, which is equal to 1.0000. This is equation number 2. So in partial pivoting, what we did is these two equations we interchanged. So equation number 1 is brought at equation number 2, so that this equation 2 becomes 1, and this coefficient of x1 will be the pivoting element, or which is far away from 0. Initially there is a 0.003, which is right now a pivoting element. So interchanging these two equations is known as a partial pivoting. But if what we do, instead of interchanging only rows, if we are interchanging rows and column both, that is, say for example we want to bring this 3.00 in first column, then this equation number 1 can be rewritten as 3.0000 x2 plus of 0.0003 x1, which is equal to 2.10001. so this is now equation number 1 is rewritten, and equation number 2 is rewritten as 1.0000 x2 plus of 1.0000 x1, which is equal to 1.0000. So this is equation number 2 now. So what we have tried here, columns have been changed. So this is called as again complete pivoting, but here only we have changed column, not a row. Now we will have another example where we will be doing complete pivoting. Let us consider another problem where we are going to do complete pivoting, and then we will solve that problem with complete pivoting. So just it was the idea to change columns and rows simultaneously, that is known as a complete pivoting. So what this complete pivoting is, there we'll see. The rows can be changed so that the largest element becomes a pivot element. So here this largest element has become pivot element. This is called as a partial pivoting. So in first case, interchanging these equations is known as a partial pivoting. The procedure in which the procedure to search the largest element from the rows and columns. Now if you see here, columns as well as rows are searched for largest element. So here we have searched columns and rows where the 3 is the largest element, and this is brought as the pivoting element. So complete pivoting is rarely used because switching columns changes the order of x, that is the unknowns, and consequently adds significant and usually unjustified complexity to the computer programs. Therefore complete pivoting is rarely used. So here we have done pivoting by interchanging the columns. Now what we do, we'll multiply second equation with multiplying for equation 1 by 1 and dividing it by 3, we get, so first equation is multiplied by 1 and divided by 3, so x2 plus of 0.0001 x1, which is equal to 2.0001 divided by 3. So this becomes equation number 3. Say, so now subtracting equation number 3 from equation number 2, from equation 2, we get, now we write equation 2 first, that is 1.0000 x2 plus of 1.0000 x1, which is equal to 1.0000. So this is equation number 2, and equation number 3 we write as x2 means coefficient is 1 plus of 0.00001 x1, which is equal to 2.0001 divided by 3. So subtracting means minus minus minus, so this first term gets cancelled, and what is remaining here is 0.9999 x1, which is equal to 1 minus 2.0001 divided by 3. This is 0.3333. So that is nothing but we get x1 value as 0.3333 divided by 0.9999, that is nothing but 1 by 3. x1 is equal to 1 by 3. So now substituting x1 is equal to 1 by 3 in first equation, so this we call as first equation. So 3.000 x2 plus of 0.0003 x1, which is equal to 2.0001. so x1 value we know, so this is 3.0000 x2 plus of 0.0003 into 1 by 3, which is equal to 2.0001. so this 3 gets cancelled. 3x2 is equal to 2.0001 minus of 0.0001, so x2 is equal to 2 divided by 3. So x1 is equal to 1 by 3, that is nothing but, and that is x2 is equal to 2 by 3. So this is how we get accurate answers by complete pivoting or pivoting. So in case of complete pivoting, rows are interchanged, along with the rows columns are also interchanged, that is known as a complete pivoting. Now coming to the scaling, what this scaling is, we will see. Now we will consider one example as 2x1 plus of 1 lakh x2 which is equal to 1 lakh. This is equation number 1. Now x1 plus of x2 is equal to 2. This is equation number 2. Now if we compare the coefficients, here the coefficient of x2 is 1 lakh, here coefficient of x2 is 1. So here on right hand side, here there is 1 lakh, and in second equation only 2. So if we compare these magnitudes of coefficient, so there is a huge difference in the magnitudes. So this difference in the magnitudes has to be reduced by scaling. So now we are going to solve this equation or set of equations by forward elimination method without scaling and without pivoting. So without scaling and without pivoting, what we do, multiplying as it is, we are going to solve using Gauss elimination method, multiplying equation 1 by 1 by 2, we get, so if we multiply first equation by 1 by 2, so it will be x1 plus of 50,000, x2 is equal to 50,000. We can call this as equation number 3. So now subtracting equation 3 from equation 2, we get equation 2 is x1 plus of x2 is equal to 2, and equation 3 is x1 plus of 50,000, x2 is equal to 50,000. So subtracting this minus minus minus, so this will be okay. So this will be 50,000 minus of 1, that is minus 49,999, x2 is equal to 49,998. So this gives us x2 is equal to 49,998 divided by 49,999. So this is point x2 is equal to 0.99999 and 9999799. So this is the value of x2. So once we know value of x2, if we substitute in equation 1, so then 2x1 plus of 1 lakh, x2 is equal to 1 lakh. So 2x1 plus of 1 lakh into 0.9999799 is equal to 1 lakh. So this gives us 2x1 is equal to 1 lakh minus 99,997.99. So x1 is equal to 1 lakh minus 99,997.99 divided by 2. This is 1.005. So this is very close to the true answer So this is how we are going to get the solution without scaling and without pivoting. Now we will solve same problem using scaling. The exact answer of this one is x1 is equal to 1. So true answer is x1 is equal to 1 and x2 is equal to also 1. This is the correct answer. But here without scaling we got x2 as 0.9999799, whereas x1 is equal to 1.005, which is close to 1 but not accurate. So it has got error. So to reduce this error, scaling is used. So what is this scaling that we see? So let us see first equation as 2x1 plus of 1 lakh x2 is equal to 1 lakh. This is equation number 1. And equation number 2 is x1 plus x2 is equal to 2. This is equation number 2. So in scaling, this 1 lakh is reduced to 1. So dividing first equation by 1 lakh, we get dividing equation 1 by 1 lakh. So just we are dividing first equation by 1 lakh, we get first equation as 0.00002 plus of x2 is equal to 1. So this is equation number 3. So now equation number 3 and equation number 2, if we, this is x1. So solving equation number 3 and equation number 2. So equation number 3 is 0.00002 x1 plus of x2 is equal to 1. This is equation number 3. And equation number 2 is x1 plus x2 is equal to 2. So this is equation number 2. So equation number 1 is reduced to equation number 3 by dividing complete equation by 1 lakh. That is nothing but this coefficient 1 lakh, which is very large, that in order to reduce the difference between these two coefficients, so first equation is divided by 1 lakh, that is called as a scaling. So now if we simplify these two equations, then multiplying first equation one by 1 divided by 0.00002, we get as x1 plus of 1 divided by this is 50,000 x2, which is equal to 50,000. So this we call as equation number 4. So now subtracting equation 4 from equation 2, we get, so we are using Gauss elimination method here. So equation 2 is x1 plus x2 is equal to 2, and x1 plus of 50,000 x2 is equal to 50,000. So subtracting this is minus, this is minus, this is minus, so minus minus gets cancelled. 50,000 minus 1 means 49,999 x2, this is minus, and which is equal to 49,998. So this is going to be similar to previous case again. So x2 is equal to 49,998 divided by 49,999. So this gives us 49,998 98 divided by 49,999. So this is 0.9999799. So this is x2. Again, by substituting this x2 in equation number 1, then we get x1 as 1.005. so there is no difference between scaling or without scaling. So if you compare in first case and in second case, so you find very similar answers. But if we are going to do scaling with pivoting, then what happens that we see. So now first equation is after scaling is 0.00002 x1, 0.00002 x1 plus of x2 is equal to 1. So this is first equation. Now this is after scaling, so this is scaling is done for this. And second equation is x1 plus x2 is equal to 2. x1 plus x2 is equal to 2. Now if we interchange these two equations, that is called as a pivoting. So x1 plus of x2 is equal to 2. We make this as equation number 1. So actually this is 2. We are going to interchange, and 0.00002 x1 plus of x2 is equal to 1. This is equation number 2. Now what we have done here, scaling is done and then pivoting is done. So in case of pivoting, largest coefficient is brought at the pivoting location, that is 1. So it has got coefficient 1. So here it is tried that the diagonal elements have largest coefficients. Now multiplying this first equation by 0.00002 and dividing it by 1. So again multiplying equation 1 by 0.00002, we get 0.00002 x1 plus of 0.00002 x2 is equal to 0.00004. So this is equation number 3. Now subtracting equation 3 from equation 2, we get, now if we subtract equation 3 from equation 2, so first we write equation 2, 0.00002 x1 plus of x2 is equal to 1, and then 0.00002 x1 plus of 0.00002 x2 is equal to 0.00004. So subtracting means minus minus minus, so this first term gets cancelled, and 1 minus 0.00002, 1 minus 0.00002, this is 0.99998 x2 is equal to 1 minus 0.00004, this is 0.99996. so x2 is equal to 0.99998 divided by 0.99996, 0.99998 divided by 0.99996. So this is going to be 1.00002. So if we consider answer up to 4 decimal places, x2 is equal to 1. So if we are considering this answer up to 4 decimal places, answer x2 is equal to 1. So now if we substitute x2 is equal to 1 in any of these equations, so x1 plus of x2 is equal to 2, and if we substitute x2 is equal to 1, x1 plus of 1 is equal to 2. So therefore x1 is equal to 2 minus 1, so that is nothing but 1. Or even if we substitute x1 as say x1 plus of 1.00002, which is equal to 2, even then x1 is equal to 2 minus 1.00002, we get it as 0.99998, so which is very close to 1. So here when we are considering answer up to 4 decimal places, this is going to be 1 and x1 is going to be 1. So probably the scaling with pivoting yields to the correct or accurate answers. So this is known as scaling with pivoting. So this is how we have completed this third unit of solution to algebraic equations. So now we'll proceed to the fourth unit of your syllabus in next lecture. So today we stop here.